Okay. So 2.6 has a handful of what seems to be almost common sense theorems. Okay. And the idea here is most of our theorems are pretty much common sense as we move throughout the year. But in order to explain to somebody why something is true, you can't just say, "Oh, that's common sense." It's not a good enough argument. Okay. I remember for kind of taking the approach of a court case, you can't say somebody is either innocent or guilty based off of just common sense. You have to have proof. You have to have logical proof. So these, I think we got 3 or 4 theorems here, and we'll talk about proving maybe 1 or 2 of them. Are those things where, if we put down some numbers here in a moment, it's going to make this statement pretty clear and pretty obvious. I think they're worded a little bit sometimes, a little bit weird, but that's really the best wording that we can come up with that eliminates anything from accidentally getting into the classification that this theorem provides that really shouldn't be. So the best way of writing what we call the congruent supplement theorem, it says if 2 angles are supplements of the same angle. Okay, or maybe if you want to rewrite it, if 2 angles are supplementary to the same angle. Okay, and then it puts in parentheses or congruent angles. So most proofs or most theorems that we come across that talk about comparing multiple things to the same thing, in this case the same angle, they will then put in parentheses that same thing could actually be 2 separate things, but they're congruent separate things. Okay, so that's kind of what that set of parentheses is talking about. So if 2 angles are supplements of the same angle, then the 2 angles are congruent. Okay, if you have 2 angles that are supplementary to the same angle, then the 2 angles you started with are indeed congruent to one another. So common sense-wise, guys, I hope that we can see that if angle 1 and angle 2, let's say angle 1 is 40 degrees. And it's supplementary. It says 1 and 3 are supplementary, or they're supplements. So if 1 is 40 degrees, what's angle 3 got to be? 140. Okay, to be supplementary, you got to have to 180, right? So that's matching that. Okay? The other statement says 2 and 3 are supplements. Well, if 3 is already defined to be 140, based off this first conclusion, or this first argument, what does that make angle 2 have to be? 40. And then it says then angle 1 is congruent to angle 2, or then the 2 angles are congruent. Well, what do you notice about angle 1 and angle 2 now? They're both 40 degrees, right? So you have 2 angles that are supplementary to the same angle, then those 2 angles are congruent to one another. Okay? Now, if we want to talk about that part or that aspect that is in parentheses there, the idea would be if that's angle 3, that's angle 1, we could have another angle 4, and this be angle 2. And the idea would be first to say angle 3 and angle 4 are congruent. If 1 is supplementary to 3 and 2 is supplementary to 4, but 3 and 4 were the same amount, so maybe here we got 3 is 140, 4 is 140, they got to be congruent. Then angle 1 is going to be 40 and angle 2 is going to be 40 if they're supplements. So what's the argument about angle 1 and angle 2 in this case? They're still congruent, right? So that angle 3 could be one individual angle, like it is in the box up there, in the yellow box. Or 3 could actually be 2 congruent angles, like 3 and 4 in the bottom. Is that a pretty obvious statement? I want to prove that. I want to go through the logic of it. Now, the reason I want to do this, and this is one of the situations where I don't want to do a whole lot of proofs today, maybe 2 of them, so I didn't print anything off for you. And I think this proof, instead of being on a separate piece of paper, needs to be in line in your notes because it's important to what we just wrote down. So I want a separate piece of paper kind of floating around. So take a moment and write that down. We'll come back and kind of analyze how that actually states the theorem. It doesn't. It says if two angles are supplementary to the same angle, that's the theorem, then the two angles are congruent. So you don't need to write what I wrote down there in purple. But what I want you, because it's already stated prior, what I want you to realize is that when we write our given and proved statements, okay, two angles are supplementary to the same angle, okay? We have to come up with specific angles to talk about, okay? So when we talk about two angles in our given, we're talking about those two angles, 1 and 2. And that statement in the given, are we saying that they are supplementary to the same angle? Are both those, when we say the same angle, are they both supplementary to angle 3? Does that kind of make sense? Okay. So our given does say that if statement. It just says it in a way that we can actually discuss specifics and be able to, in our statements here in a moment, write down some convenient facts and logic. Okay. It then says, then the two angles are congruent. Well, the two angles, those would have been 1 and 2. So that's what we're seeing here with that in orange. And it's not a very good color to use. So when we say two angles, we're talking those two angles, again, then referencing back to those. And that's the process, then, that we'll go through every single time that we see a theorem that we need to prove, because the theorems in general don't indicate specifics, right? They don't talk about specific angles. So you have to be able to decide what you want to call them, and make sure that what you say and you're given matches the if. What you want to say and prove matches the then. All right, so writing down our given. Do this. Angle 1 and angle 3 are supplementary. Angle 2 and angle 3 are supplementary. And that is given. Statement 2 then. Okay, remember what that sheet that I gave you the other day said? You're going to write your given down, and then you're going to go through your vocabulary. And in our given, there are two vocabulary words, right? They're the same, but there's two situations where we identify things as supplementary. If they're supplementary, what does that tell us about 1 and 3? Good. They're going to add up and set equal to 180. So measure of angle 1 plus the measure of angle 3 equals 180 degrees. And we know that because that's how we define supplementary angles. They're angles, two angles whose measure sum to 180. If that's the case with angles 1 and 3, can I make the same argument with 2 and 3? Can we say the measure of angle 2 plus the measure of angle 3 equals 180? That's using that second situation where we had supplementary in our given. Now, it's going to be the same reason, so I just combine them in the same step, so I don't have to write definition of supplementary angles twice. Is it okay with everybody? Okay. Now my hope is that eventually we recognize that when we get to this stage in this proof, and in any proof that is like this, we're done almost. Okay? We just have to now make the links that allow us to get to our final statement. But we in actuality, we've already done this proof. Okay? And I'll make that connection to you later. But what do you notice about that 180 degrees and that 180 degrees? They're equal, right? They are the same exact number. So what's that tell you about the two things that add up to give you that 180 and the two things that add up to give you the bottom 180? They got to be equal too. Those sums have to be the same if they both add up to 180. So step 3 is going to be measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3. And we talked about this on Thursday. I think it was Thursday, it might have been Wednesday, where I gave you this picture over here, right, with the algebra that we've done before. And if we knew we had this equation and that equation, because these two y's were the same, we could set these expressions equal to each other, right? Just remember what that process was in algebra? Did you replace in either one of those? Let's say take the top one. Did you replace the y with negative x plus 7? Because the y and the negative x plus 7 were the same thing, were they not? When you replace something with the same thing, or something that it is equal to, what's that called? Lexi? Substitution. Good. Okay. So that's what we did here. We took basically what we've got here. This line 3 is the exact same thing as that line right there. But instead of writing 180 on the right-hand side, we wrote what 180 was equal to on the right-hand side. Right here, we're defining that 180 is the same as 2 plus 3. So that is substitution. Now, some people might argue this, which I would agree that this is fine. They might say measure of angle, what do we have, 1 and 3, 2 and 3? I might say 1 plus measure of angle 3 equals 180. And then in the row after that, they might start off with 180 is equal to measure of angle 2 plus measure of angle 3. And they say, this object here, which maybe is an idea or concept that we call A, is the same as this concept here, which maybe we call B. And if that's B, then that's got to be B, right? Does that make sense? And then this concept here would be C. You guys remember talking about if A equals B, but B equals C, we can then jump to the conclusion that measure of angle 1 plus measure of angle 3 equals the measure of angle 2 plus measure of angle 3. Does anybody remember what that logic is? I think I showed it kind of by doing this. We can take that statement and merge it. And these 180s overlap. So if those 180s overlap, don't these two things have to be equal? Anybody remember that property? If A equals B, but B equals C, then A equals C. Craig? Transitive property. Good. Okay. So if you see that, I think that's a valid argument. Okay. There are times, guys, where substitution is substitution, and that's the only thing it can be. There are times with transitive property, it can be transitive property, and that's the only thing it can be. But I think there are times as well that you can argue one or the other. Okay? So I would not have an issue with you writing transitive property there. On, the way you're going to see them in Math Excel, some of them, sometimes I create the proofs and instructor created proofs, and you got to type stuff in. And in the background, I might allow substitution and transitive. Okay? There are times where you got drop-down windows. Well, substitution might be there, transitive might not be there. Transitive might be there, but substitution is not there. Does that make sense? So I want you guys to be kind of aware of the multiple options you have. The end of course exam, I've seen examples where you have to write the whole proof by yourself. Okay, you type it out, paragraph form, and explain your logic that way. I've seen where they're kind of like Math Excel, where your drop-down windows are what you're going to fill in your reasons and statements with. And I've also seen where they kind of give you a structure. They say, here's 5 statements, here's 5 reasons. And at the bottom, they've got like 10 statements that you can click on and drag and put in different spots. Maybe substitution is not an option in one of those boxes, but transitive is, or vice versa. So I want us to be aware of multiple options here. Okay? But now, what do you recognize that is on both sides of this equation in line number 3? Good. Measure of angle 3. Now, we don't know what it is. We don't know how much that is. Okay, but we know it's a measurement, so it's referring to a number, a real number. And it's on both sides. So it's balancing the equation, right? Well, if I remove it from both sides, is what I'm left with still balanced? So let's remove that object that's on both sides. Whenever you recognize in a proof that you have the same amount on both sides, get rid of it. Because they cancel each other out. But if I get rid of it, how do I remove something from both sides in an equation? What operation do I use? Is it addition, subtraction, multiplication, or division? That's subtraction, right? We cancel measure of angle 3 with measure of angle 3 through subtraction. So that's my reason. These are both properties of equality. It's not a big deal right now if we write that or not. I'm not too concerned about it. But now I've got measure of angle 1 equals measure of angle 2. And if I have two measurements that are degrees, so we know they come from angles, shouldn't we be able to take those two angles as shapes and lay them on top of one another? And that idea says if the angles have equal measurements, then the angles themselves are congruent. And what allows us to go from equality to congruence, that step will always be the definition of congruency. And if we were to compare that to what our proof statement was at the top, they're the same, so we know we're done. Okay. Now, we did something like this. Like I said, I think it was Thursday. Come up here. We proved this theorem here about vertical angles. So that thing on the right is what we just did, and the thing on the left is what we did Thursday. I'm going to zoom out so we can see them both. And I know it's kind of messy, but let's kind of do this. Let's say, a different color here. All right. Would you guys agree that that yellow statement right there is comparable to that yellow statement? Now, the reasons are different. On Thursday, the yellow statements on the left, we had to make the argument that they were supplementary because of a linear pair. And the argument on the right that we just did, it was given to us. Okay, so regardless, though, it's a fact. Okay, now let's look at what we just did compared to what we worked on last week. If I highlight that statement right there, okay, we knew in the yellow above it that we had two sets of angles that are supplementary, so we wrote down what that meant for us, and it gave us these two equations that equal 180. Is that the same thing that happened over here? Does that make sense? So far, the yellow and the pink highlighted sections of these two proofs, even though they're different proofs, they're different statements, those are consistent. And then, today, we recognized that there was something on both sides, so we were going to first use the substitution process and equate, because they both had two equations, basically a set equal to 180. So we used the substitution process to create that next equation. But then on Thursday, you see I kind of wiped them out, crossed them out here. So I can't remember what they were. We canceled those out, and then today we canceled them out here, right? And does that give us that green statement there? And over here, it gives me that green statement, and you can see that the reasons were the same. And then those last statements, you see that those last statements are comparable. They're the same, right? So my hopes are, even though we realized on Thursday we proved that vertical angles are congruent, today we proved that two angles supplementary the same angle are congruent. So completely different phrases. But we use the same logic to prove them both true. Okay? What I want you guys to understand, these are patterns. Okay? And from now on, at any time throughout the year, if you make kind of the declaration that you've got two sets of angles that are supplementary, you are going to go through those 5 steps every single time. And generally speaking, that'll be enough to eventually get you to where you want to be, get you to what you wanted to prove. Okay? So those 5 steps, and this is the idea that when you see throughout proofs, kind of key statements, like angle 1, angle 3 are supplementary, angle 2 and angle 3 are supplementary. That's a key statement that is then going to generate 4 other steps that we can almost be robotic about. We know that they're going to follow every single time. Okay? I don't know how many proofs we're going to do. Let's say if we do 100 proofs, I would say, guys, that in each one of those proofs there's going to be a series of patterns. But of all the 100 proofs that we do, they're probably going to break down into 4 or 5 different structures. And if we can start to understand these patterns and these structures, proofs should be relatively simple, or simpler than if we approached each one as something completely new. Does that make sense? Would you rather approach 100 problems like they're 100 new problems, or would you like to approach 100 problems like maybe they're, 5 or 6 new problems? Does that make sense? Okay? So we can categorize them that way. It's going to make things a lot easier. But obviously we have to recognize that. We have to be able to remember that generates 4 other steps. Okay? So as we're doing, I don't know if we talked about this on Thursday, but as we're doing proofs, so the proof that we did here on Thursday and the one that we just did, those are proofs that get us to prove something. Don't write this down, but those are things that get us to prove actual factual statements. Okay? This is just a generic proof that allows us to practice using statements and reasons to come to a conclusion. Okay? It will be true, but generally the theorems that we prove are statements that we're going to see over and over and over again, the relationships that we're going to see over and over and over again. If I was to start with this, if I got angle 1 and 4 here and they're congruent, prove that 2 and 3 are congruent. So this is kind of like the idea, if I've got the XY plane, I got the second quadrant and the third quadrant, they're both 90 degrees, then the first and fourth quadrant's got to be 90 degrees as well. That's what we're kind of getting at here, but we don't see that enough beyond this example to kind of declare that to be a theorem and that it'd be useful in other things that we do. Does that make sense? So this is just a practice problem that gets us to use our properties and our statements, but the conclusion really isn't anything that is going to kind of carry over to another problem, where what we just did, okay, this proof here of this theorem, and being able to say then that this statement, if 2 angles are supplementary to the same angle, then the 2 angles are congruent, is a fact. That is something that will carry over to many, many, many more procedures and questions that we operate within in the course. Okay, so that's why we call it a theorem. It's because it's going to be something that gets used over and over again. All right, so before you write this down, this is kind of a note-taking strategy here that I think is important. If I read this theorem and I compare it to the theorem that we just wrote down and the proof that we just did, okay, if 2 angles are complements of the same angle or of congruent angles, then the 2 angles are congruent. Is that saying the exact same thing the last theorem did, but takes the word supplementary out and replaces it with complementary or complements? That make sense? So what would be a better thing? Would you want to write that down knowing that you already have this written down, or next to this, would you just maybe put an asterisk and say, true for complements 2. And having that theorem and then that asterisk statement now allows you to write down 2 theorems with really only having to write down 1. Does that make sense? Okay, so you can take that word supplements out, replace it with complements, and you get a true fact. Okay, now if I wanted to prove it, this, well, what's the only thing that changed? The word supplements to complements, right? Supplements add up to 180. Complements means adds up to 90. Okay? So what I would do, instead of having, and I got the proof here, I got the template here for us, but what I would do is I would say proof is exactly the same as supplement theorem, but 180 replaced with 90. And now you've got a statement that would allow you to generate that proof when need be. Does that make sense? What I like to do, I like to give you, these supplementary proof in class and work through that and talk through that, discuss and all that kind of stuff. And then on a test or a quiz, I give you the complements version. Okay? Because one, I want you to be able to draw the connection to, something that we've already done together, but how can we use that kind of practice that we use together to work on something and to arrive at new facts or new conclusions on something that we maybe haven't worked together on. Does that kind of make sense, though, and taking notes? I think one of the skills that is going to be very, 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 very important, and I think a lot of us are going to find out that we have to change the way we take notes when we get to college, is that we can't write down everything the professor writes down. We can't write down everything they say. We have to be able to write things quickly, okay, but at the same time don't lose meaning, because you're going to find out that when you're in a class of maybe 300 people and you raise your hand to say, hey, can you go back a slide, they're not going to see your hand raised, and if they do, they're not going to call on you, okay? But if you need that information, you got to develop those skills. Does that kind of make sense? I think that's one of the things that hinders most students in math is from 2nd grade to 8th grade, we really haven't been taught how to take notes, okay? I think if we were taught in those grades how to socialize, how to stay organized, how to take notes, how to prioritize, and not so much worry about the facts, the math facts, and all that kind of stuff, high school math would be so much easier. High school science would be so much easier. Okay. The next theorem says all right angles are congruent. All right angles are congruent. Hopefully that is something that is trivial almost, okay? To the point where, if I have two angles that are right angles, then they're both 90 degrees. Well, that means their measurements are the same. That means they're congruent, okay? A fact that we use quite a bit, okay? It's a very useful theorem. Notice this one doesn't have a special name. It's just called Theorem 2.4, like I told you last week. In another textbook, it might be Theorem 2.2. It might be a Theorem 3.5. So we want to remember this, that it's just a theorem that all right angles are congruent. No special name with it. We do use it a lot, but usually the theorems that have special names, like the last two had a congruent complements theorem, congruent supplements theorem. They have special names like that. It's probably because we're going to refer to them a lot throughout the year. Okay. The angle addition postulate, the segment addition postulate, they had special names because the amount of questions and procedures that we'll apply that concept with is almost endless throughout the course. You guys agree that's a pretty easy concept? Okay. Now think about this. If you got two angles that are supplementary, and they're congruent. If they're supplementary, what do you have to add up to? 180. If they're congruent, they have to be the same. They both have to be 90, right? And if that's the case, they both then have to be what kind of angles? If they're both 90 degrees, they're going to be supplementary, but classified. And if a 90-degree angle is classified as a, what do you name it? Not acute. What's the breaking point between acute and obtuse? It's a right angle, right? Okay. So, and that's the idea. And somebody said, well, right angle, last period, right angle is the same thing as 90 degrees. I don't need to make that argument. Well, you do need to make that argument if somebody doesn't know that vocabulary. Does that make sense? You need to be able to lead these people that are reading your work to maybe logical ideas about vocabulary that they don't know. And the argument that I said, okay, look at this shape right here. That's a hexagon, right? Would you guys agree that that's a segment? Does that make sense? That's a segment, okay? Does anybody know what that segment's called for a hexagon? So if I start using this word opossum, and I never told you what it was, you'd be completely lost, right? Okay? That segment in that hexagon is called an opossum. But if I never introduced that to you, you were not aware of that vocabulary, you would have no idea what it meant. So people that don't know what right angles are have no idea that it means 90 degrees. Or people that don't know anything about 90 degrees equating to a right angle would have no idea about our jump from being done and saying, oh, well, it's 90 degrees, right angle, same thing. I agree with that. But we have to be able to describe that and discuss that concept. Okay? So we don't want to take any assumptions about what people know as they read our proofs. Okay? I want to work real quick on developing a proof for this. Okay, so our given, if you remember what your given is going to be, it's that there. That's your given. Okay, so we need to talk about specifics though. So what do you want to call your angles? It says two angles are congruent and supplementary. You guys okay with saying like angle, using the picture here, let's go angle 1 and angle 2 are supplementary. And let's also say that angle 1 is congruent to angle 2. That says what this if statement says, right? The then statement says each is a right angle. All right, and this is maybe a little bit, I don't know, more kind of deceptive maybe. But what we can do to prove that or to match up to this is to say that angle 1 is a right angle. Now you can say angle 1 and angle 2 are right angles as your proof if you want to. But my thought is, if I say angle 1 is a right angle, but then my given was that angle 1 and angle 2 were actually congruent, does that at the same time say they're both right angles? Okay. I'm not really worried about a picture here. So let's just kind of write down our statements. Give myself a little bit of room here. So angle 1 and angle 2 are supplementary. Angle 1 is congruent to angle 2. Another thing, maybe as you guys are writing, because I know I've been in your seat, I hated writing proofs as we worked through them together in a class. So develop maybe a strategy, because you just wrote the given already once, right? And now it seems like you're doing the same thing over. Maybe in step 1 on statement and reason, you just write given for both of them, and then link to it and understand that whatever this phrase here was goes right there. So it allows you to maybe quickly write these things down in class. Number 2, we've got a vocabulary word here, right? We've already used this several times today. If I've got two angles that are supplementary, we're always going to say that. That's one of those pattern type statements. Okay, so those two statements, the statement of supplementary and then the statement of 1 plus 2 equals 180, always need to come together. And the reason? Definition of supplementary angles. This next statement you'll get used to using, but the idea is now I've got an equation, so I can start doing some algebra inside that equation. If I ever develop an equation, I want to start doing algebra, one of my tools for doing that algebra is substitution. So I want to replace something here, but I need things to replace. Right now, this says a shape cut and paste on top of another shape. I can't replace that measure of angle 2 with angle 1 because one's a shape, one's a number. Does that make sense? One's a shape, one's a number of degrees. So what we need to do is say, well, if these two angles are congruent, then the measurements of those two angles are equal. And that's the definition of congruency. Okay? That's almost kind of a formal thing that we have to go through so we can actually do the substitution. But now, I'm going to rewrite statement 2, measure of angle 1, plus, instead of measure of angle 2, I now have that ability, right? I now have that substitution I can make. Wherever I see 2, replace it with 1. And again, that's substitution. We've been using that several times now. Now, at this stage, how many measure of angle 1s do you have? If this was x plus x, you'd have 2x, right? And that's all measure of angle 1 is. It's a symbol. It's a variable for an unknown value. So now I have 2 measure of angle 1s, right? So let's combine like terms. If you have 2 measure of angle 1s, what would you do to find 1 measure of angle 1? Or if you had 2 x's equal 180, what would you do to solve for 1x? Divide by 2. Okay? Now, somebody in the last class said, well, we can stop there. Because everybody knows when you have an angle equal to 90 degrees that it classifies as a right angle, right? But not everybody knows that. So that's why we need to go one more step and say, now that I know the measure of angle equals 90 degrees, now I can say angle 1 is a right angle. And that reason is the definition of right angles. And the idea then is that anybody that's reading this that does not know what the definition of right angle is, if they understand how the structure of proofs work, they can look at that. Okay, they said measure of angle 1 equals 90 degrees. And they went and said angle 1 is a right angle because the definition of right angle. Oh, the definition of right angle must clarify that it's any angle that has a 90-degree measurement. Does that make sense? Okay, and that's how our proofs need to be conducted. We want to make sure that we finish, okay, with the statement that we're trying to prove, kind of verbatim. We don't want to stop at 90 because our proof doesn't ask us to prove it to be 90. It says prove it and classify it as a right angle. So they need to match. Okay. Your homework for tonight, guys, is there's a series of proofs in it that are going to ask you to do fix most of the statements and reasons, and maybe like 2 or 3 of them are blank, and you got to pick them from a drop-down window. And there's some then algebraic questions that kind of target these supplement concepts and some of the vertical angle concepps. Okay. So give it that a shot. We'll talk about that tomorrow. And hopefully start chapter 3 tomorrow.